Hey guys, we're going to start a new chapter today. We're going to start chapter 6. We will not have time to finish this chapter before we leave for Christmas break. So we are going to go ahead and talk about graphing systems of equations, and we're going to talk about substitution before we leave. And then once we get back from Christmas break, we'll pick it up, review this stuff, and then proceed on to chapter 6. So I think you guys will find today's lesson pretty easy because we all know how to graph. In fact, just this last week, we talked about how to graph inequalities on a graph, on a coordinate plane. And the same thing is going to happen today. We're going to be graphing on a coordinate plane, but our goal is going to be finding the solution for the system of equations, and we're not going to be dealing with colors and inequalities. All right, so let's go ahead and follow along. Just like normal, I know I'm not here today, but with the video, I'm still here, and you guys are going to still take notes as usual, so you do need to make sure you're writing down things as we go. Alrighty. So the first thing I want to do is review graphing. So our first example is 2x plus 3y equals 15. And our goal is to graph this equation. So we have a couple different choices. Choice number one is we could change this into y equals mx plus b form, or as you guys can see, it is in standard form and we could just find our x-intercepts and our y-intercepts. So I'm actually going to do the x and the y-intercepts because this looks a little easier for me. So we're going to do the cover-up method. So everybody cover up the 3y. We're going to divide by 2 on both sides, and that's going to give us x equals 7.5. Now, I know for some of you that's already going to drive you crazy because you're like, but it's a decimal. That's okay. We can have decimals when we graph. So the same thing's going to happen over here. Again, cover up the x. We're going to divide by 3 on both sides, and that's going to give us y equals 5. So now we have an x-intercept of 7.5. So we're going to go over here to the 7. Here's 8. And of course, 7.5 would just be halfway between the 7 and the 8. Then we have y equals 5, so we're going to go up to the 5. So 1, 2, 3, 4, 5. Put our point here, and then just use some kind of straight edge to then graph the line. Okay, so everything I've talked about so far, this is just a review of graphing. All right, let's go ahead and take a look at our second example. This one you guys will see is already in slope-intercept form. So since it's in slope-intercept form, we need to identify our slope and our y-intercept. So our slope is 1/4, and our y-intercept is -3. So we're going to always start with this first. And one of the things I noticed about you guys last week is some of you wanted to start with the slope, and I'm not really sure where that came from, but we always start with our y-intercept first because it gives us a launching point. So we want to start down here at -3, and then remember that for slope we just want to know how much does it rise and how much does it run. So going to the -3, we're going to go up 1 over 4, and then we can go ahead and connect our points. All right, so again, that's a review of graphing. All of that should be old news to you. All right, so let's go ahead and dig into our vocabulary. So today we're going to be talking about systems of linear equations versus the inequalities that we did last week. And a system simply means it is 2 or more. And for Algebra 1, we're dealing with 2 equations. Once you move on to Algebra 2, then you'll be dealing with 3 or 4 equations at the same time. Also, we're going to be looking at what is the solution of the linear equations. And that simply means any ordered pair, and that's your special vocabulary word to insert on your paper right now, any ordered pair that makes all of the equations in a system true. So we're just looking for what x and y coordinate, what point on the graph makes that true. All right, so let's go ahead and take a look at a few examples. If we have 2, -1, and we have this system of equations, our goal right now is to decide if 2, -1 is a solution for this equation. So all we're going to do is we're going to take the 2, substitute it in for x, the -1, substitute it in for y. So if I take 3 times 2, that equals 6, and 2 times -1, that equals -2, does 6 plus -2 equal 4? Of course, the answer is yes, so we know that that works. But remember, for it to be a solution for the system, it has to work for both equations. So we're going to plug the 2 in for x. We're going to plug the -1 in for y for the second equation. So that's going to give us -2 plus 3 times -1 is -3, and at the end it says -5. So does -2 plus -3 equal -5? The answer is yes, therefore this one is a solution. All right, so I'd like for you guys to go ahead and put yes off to the side. So we know that this one is an ordered pair. It is a solution for this system. All right, let's go ahead and try the fourth one here. I'm going to go ahead and give you guys a moment to plug each one in and see if it works. Alrighty, so you guys should have already plugged it into the first one by now, and you should have already recognized something. As soon as you put the 0 and the 3 in here, 0 plus 3 equals 3. It does not equal the negative 2. So we don't even have to plug it into the second equation because we already know that if it doesn't work for the first one, then it's not going to be a solution for the system. So for this one, we're just going to write no off to the side. All right, at this point, I'd usually ask you guys if you have any questions. Since I'm not here to answer any questions, I'm just going to have you guys just take a moment. You guys have 15 seconds. Lean over to a partner if you need to ask a question, see if you can get any clarification from a partner. Alrighty, time's up. Let's go back to the video here. So number 5, we're going to go ahead and skip that one because I really feel like you guys probably have this down pat by now. So let's talk about systems of linear equations. This chapter, there will be 3 different ways that we can solve a system of equations. We're going to be looking at graphing today, substitution for the next couple days, and like I said, elimination method when we come back. So now let's go ahead and focus on the graphing. When we're graphing a system of equations, there are going to be 3 things that can happen. We're going to get 2 lines that intersect, and when we have 2 intersecting lines, then that means it's going to have one solution. We're also going to have, sometimes when we have parallel lines, and if they're parallel, then that means that they're never going to intersect, so there's no solution. And then there will be times where we have 2 equations that are identical, and that means when we graph them, they're just going to lay right on top of each other, and so we're going to have an infinite number of solutions, or what we also call all real numbers. So there's just some identifying characteristics that I've already written on your paper here, and I'd like for you guys to use those as you prepare for the next test that we have. All right, so here are the steps that we're going to do. We're going to put both equations in slope-intercept form, or we're going to find the x and y intercepts. Once we have that information, we're going to graph both of those equations, and after we graph it, then our goal is to figure out where do the 2 lines intersect, and then that's going to be our solution. All right, so let's go ahead and start with our first one. You'll notice that both of these equations given are in slope-intercept form. So we're going to identify the slope and the y-intercept. So for the first one, we have m equals 3 and b equals -7. And as we know, putting our slope in a fraction form will help us because it will allow us to have our rise and our run. So we're going to go down here to b equals -7, and we're going to go up 3 over 1. And I would like for you guys to do this several times. So we're going to continue going up 3 over 1, up 3 over 1, up 3 over 1. Use like the side of your binder or book or something as a nice straight edge. It will be super important for these lines to be straight. I don't want any curviness because if they're not straight, then you're not going to be able to figure out where do they cross. All right, so now let's go ahead and go to our second one. I'm going to use a different color just to allow it to show up on here. You guys should continue using pencil unless you think using 2 colors would be helpful. So m equals -2. I'm going to put that over 1. And b equals 3. I'm going to go up to 3 on my y-intercept here. And then because it's a -2, that's going to tell us to go down 2 into the right 1. So down 2, right 1, down 2, right 1. And that's right where we can stop because as you will see, we just hit another point that we already had graphed. So this right here is the solution for our system. That point is over 2 and down -1. So we would say that the solution for this system is 2, -1. And as we know, we can always check ourselves by plugging it back in. For this one, I am going to plug it back in just so that we can make sure it is the correct answer. So I'm going to take the 2, I'm going to plug it in for x, I'm going to take the -1, I'm going to plug it in for y. So I have -1 equals 3 times 2 is 6, and then I have 6 minus 7. And 6 minus 7, of course, is -1, so we know it works for the first equation. Same thing's going to happen again. Plug 2 in for x, plug -1 in for y. we have negative 1 equals negative 2 times 2, which is negative 4 plus 3. Negative 4 plus 3 equals negative 1, so it works. So the cool thing about this section, you should never get a wrong answer. And the reason is, you can always plug your solution back in. If it's wrong, then you need to go back and regraph it again. All right, let's go ahead and roll on. Let's take a look at example number 5. Okay, so for example number 5, you're going to see that the first equation is in standard form. The second one is also in standard form. The first one is a little different though. I want you guys to take a look at this. If I take 3x plus y equals 11, and I cover up the y to figure out what x is, I am going to get a decimal. Now, unlike the first one, this one is not going to work out nice and pretty. It's actually going to be 3 2/3, or 3.6 repeating. Honestly, that one's a little bit tougher to graph, just because it's a repeating number. It's not like 7.5 where it's halfway in between. So I'm going to suggest for this first one that we change it into y equals mx plus b form so that we don't have any issues with that. So I'm going to take this, 3x plus y equals 11. I'm going to get y isolated by subtracting 3x from both sides, and that's going to give me y equals negative 3x plus 11. So by doing that, now I know my slope is negative 3 over 1, and my y-intercept is 11. All right, so let's go ahead and go over here. We're going to go up to 11. I know it's a little bit off your graph. That's not that big of a deal. It's just the next line above it. And then we're going to go down 3 and over 1. Down 1, 2, 3, over 1. Down 1, 2, 3, over 1. We're going to keep that pattern going. All right, again, use a nice straight edge here. Keep your line straight as you create that. All right, now let's go to our second one. So the second one, it actually works out really nice and neat when we do the standard form and do the cover-up method. Because as you'll see, when I cover up the y, I get x equals 6. All right, there's my x-intercept. And when I go to my y, I'm just dividing by negative 2 on both sides. That works out really nice too. Y equals negative 3. So I can go ahead and graph my x-intercept of 6 and my y-intercept of negative 3. And then again, be really, 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 really straight with the line. And you will find out that it crosses right there. That's 1, 2, 3, 4, and down 1. So my solution for this problem is 4, negative 1. I'm not going to take the time to plug it back in, but just know that you always have the ability to plug 4, negative 1 back in, and then you can see if it works for both equations. Alrighty, I'm actually going to stop right there for a moment. I'm going to give you about 15 to 20 seconds to lean over to a friend if you need to get anything clarified. Alrighty, let's go ahead and move on to example number 6. Do you notice anything unique about the equations on example number 6? Normally this is where you'd raise your hand and I'd call on somebody, but since I can't call on somebody, I hope that yes, you're noticing that there is something unique. What you should be noticing right here is that the coefficients of x are exactly the same. And so what we have here is going to be a parallel situation. It's parallel because we have same slopes. And if it's parallel, then that means it's never ever going to intersect. So that means that for this problem, the answer is going to be no solution. Now you are welcome to graph both of these to identify that, but just trust me, they're both going to be going the same rate of negative 2, and therefore they're not going to cross. So it's no solution. Alrighty, let's go ahead and flip our papers over. We're going to take a look at example 7 here. For example number 7, I'd like for you guys to go ahead and work that out. I'm going to give you just a moment to go ahead and find the x-intercepts, y-intercepts, and then you're going to figure out where it crosses. Alrighty, so while you guys were working on this, I went ahead and graphed it up here as well. You'll see the x and y intercepts for both of those, and then you'll see that once you graph those, it does cross right here at this point, which is at -3, 1. So the solution for this problem is -3, 1. Alrighty, let's go ahead and roll through this here. Alrighty, we're going to go ahead and skip number 8. If you'd like to come back to it for extra practice, that is totally okay. And we're going to go ahead and finish off our time together by looking at example number 9. So for example number 9, you have y equals x plus 5. We can find the slope, which is 1 over 1, and our y-intercept is 5. So we're going to go ahead and graph that. Here's y-intercept at 5, up 1 over 1, up 1 over 1, up 1 over 1, and go ahead and create that line there. And then for our last one, it's a standard form, so I'm going to go ahead and cover this up. When I divide by -2 on both sides, that's going to give me x equals -5. And when I divide by +2 on both sides, it's going to give me y equals +5. So x equals -5, and y equals +5. And as you guys will see, when I create that line, it's the same line. So for this particular problem, those two equations are the same. While they don't look the same, because one's in slope-intercept form and one's in the standard form, when we graph those, they have the same y-intercept. They're going up 1 over 1, up 1 over 1, same slope. Therefore, the solution for this problem is infinite solutions. These are identical equations, so we would say that they have infinite solutions. Any point that falls on these lines will be a solution. All right, I know there's a little bit more to your packet. That is something that we're going to cover at a different time. But today, this is all you need to know: how to graph it, how to figure out a solution, and know the difference between one solution, no solutions, and infinite solutions. There's going to be some practice problems coming to you, and I hope you guys have a great day.